Hey guys, it's Miss Griffin. We're taking a look at Unit 3, Skill 3A. So there's two parts to this. I'll also be doing the 3B video, so hopefully we can talk about like using the same language as we go through this process. So we're going to start with solving 3x3 systems that are a little bit easy. Next video we're going to get into ones that are a little bit more challenging, but not by much. So we've got this example here. It's got these three equations and they want us to solve this system. So we should have an answer that has three variables in it, because you'll notice that there's an x, a y, and a z here. So we're going to list our answer like this with an x, then the y, and then the z. We always go in alphabetical order. So if it were letters A, B, and C, they go A, then B, then C. So we've got our steps listed over here off to the side. The first thing you want to do is actually find the answer in your calculator. How cool and amazing is that you could find your answer right in your calculator before you do anything? So I'm going to show you how to do that in a quick little video. Okay, so the first thing we're going to do is go to Calculate, or a new document with a calculator. I don't want to save the old document that I had, but I do want a calculator. Okay, so our first step is to hit Menu. That's this button right here, Menu. And then our steps over off to the left say to hit 3 for Algebra, and then 2 for Solve System of Linear Equations. That's exactly what we're doing, is solving a system of linear equations. However, we don't have 2 equations, but we have 3. So I'm going to hit Delete, and then I'm going to change the number of equations to 3. And then that will actually automatically update your variables to say x, y, and z. So I'm just going to actually hit enter once I have 3 written in there. And then it gives me this, and it kind of looks a little bit like what we have going on our paper, where we have these spots to write 3 equations. So now I'm literally going to type those equations, 2x plus y plus z equals 15. So I'm going to use my number pad and my letters x, y, and z down here at the bottom. When I get ready to put the equal sign in there, I'm going to use the equal sign that's just below the control key. Okay, so we do need every single part of that equation. So it starts with 2x plus y plus z, and then again the equals button right next to control, and then 15. Then I'm going to hit the down button to move down to my next spot to type the equation. So it's 6x minus 3y minus z equals 35. So I'm typing it the exact same way that I see it on my paper, because once I type this in, it's actually going to solve for x, y, and z for us. Now we can't just use that as our answer. We have to actually do the work to get to the same exact answer as what our calculator is telling us. So I've got all 3 typed in. I'm not going to touch anything else. I'm just going to hit enter. And it tells me that the first variable will be 7, the next will be 3, and the next after that will be 2. So the reason that we want to say it in the order of x, y, and z is because our calculator gives it to us in alphabetical order, x, y, z. So 7 is x, y is 3, z is -2. So we're going to actually put that on our paper in that spot that says solution with the big cloud around it. Alright, so as we just said, we've got to put those numbers in our solution. And so we've got 7, and then 3, and -2. So this is again going to help us make sure we're on the right path as we solve for each variable individually, moving through this process. So then after we have found the answer, we've got to actually do the work to get to our solution. So we're going to start by labeling each of these equations as A, B, and C. And I want you to make sure that it's a capital A, capital B, capital C, because like I mentioned earlier, these variables could be A, B, and C, but it would always be a lowercase letter to represent a variable. So we're going to decide on one variable to eliminate immediately. So when I look at my x's, I'm just going to highlight x's versus y's versus z's in a couple different colors. You don't have to do this right now, it's just to get us to think about this. So here when I'm looking at my x's, I have a 2x, a 6x, and a -4x. And it says to eliminate one variable, we must make sure that they have the same constant and the opposite signs. I actually want you to change this to the word coefficient, because that's a better word here. Coefficient instead of the word constant. Because coefficient means the number in front of the variable. So again, looking at my x's, I have a 2, a 6, and a -4 as my coefficients. We want them to have the same coefficient and opposite signs. Like, yes, these are all even, and maybe we could multiply by something in order to make the x's cancel, but I can almost guarantee you that there's going to be a variable that cancels more easily than having to multiply these. The next one I'm looking at y's, I have a 1y minus 3y positive 4. None of those numbers are the same, and only some of them have opposite signs. When I look at the z's, though, technically there's a 1 in front of each of these because they don't have a coefficient, so that 1 is there. We've got a positive 1 and a negative 1. Ooh, same coefficient, opposite signs. Great so far. We have a negative 1, negative 1. So somehow I can eliminate z's by just simply adding. Sometimes, though, you might have to multiply. That's what we're going to fill in this next blank. You might have to multiply one of the equations by a constant and or a negative 1 to get the variables to disappear. Because remember, again, you want the same coefficient and opposite signs. So it looks like we're going to be able to eliminate z first. And we're going to do this by adding the two equations. Okay, add two of the equations, and then we'll circle the remaining thing. So we're going to start by adding a with b. It will not always be a with b. It's just because I'm noticing these two are opposites in terms of the z's. Okay? So we start with the equation 2x plus y plus 1z. If you want to put a 1 in front of the y, that's cool too. Equals 15. And 6x minus 3y minus 1z equals 35. And I'm going to put like the addition bar under it with literally a plus sign. Because what you're going to do is sum your x's, your y's, your z's, and the numbers to the right. Okay, so adding straight down, we get 8x. 1 minus 3 is negative 2y. The z's cancel, so that's a great thing. 1, take away 1. And then these numbers off to the side sum to 50. And now we're going to call this equation D. So I'm going to circle this. We're going to come back to it in just a minute. This is equation D. Step number 2 is to repeat the same process to eliminate the same exact variable. So we still need to eliminate y. But this time we're going to use equations A, B, C in a different way. We can repeat one of the same equations, but we don't want to do A plus B again because that's not going to work. So I'm again looking for same coefficient but opposite signs. It looks like I could maybe do A and C because they have the same coefficient on the z's, but they are opposite signs again, just like A was with B. So we're going to add A plus C. And again, it's not always going to be A plus C. It's not always going to be A plus B. You have to decide based on your own numbers in the problem what you're going to want to add to one another. So we've got equation A, which was the 2x plus 1y plus 1z equals 15. And then we have negative 4x plus 4y minus 1z equals negative 14. And again, we draw the bar, we do our big plus sign because that means we're adding straight down. So I combine these numbers out in front. 2 minus 4 is negative 2x. Oops, I keep zooming and moving this. Negative 2x, and then combine this. 4 plus 1y is plus 5y. Negative 1z plus 1z cancels, and then 15 plus negative 14, that's just a positive 1. And this will be equation E. I'm going to circle it because that's what our process says. Circle the two remaining equations. Because now we're going to use those remaining equations and figure out how to cancel the next variable. Using equations D and E, eliminate another variable using the same process. So remember how it said that we might need to multiply an equation or more than one equation by a constant or negative 1 in order to get the variables to disappear? With this equation, we have an 8x, a negative 2x, and then we have a negative 2y and a positive 5y. So none of those have the same coefficients for the given variable, whichever one you're looking at. So we're going to have to multiply at least one of the equations by a number. It seems to me that it might be easy to figure out how to make a negative 2x into a negative 8x so that we can just add and eliminate the x's. So we're going to do, let's see, equation D plus, well, we have to multiply this times a positive 4 to keep it as a negative 8 so that they are the same number but opposite signs. So we're going to do D plus 4 times our E equation. So the D equation just gets written as it is. That's the 8x minus 2y equals 50. But then everything here has to be multiplied by 4. Every single individual piece. So the 4 times the e equation becomes a negative 8x plus a 20x, or 20y, excuse me, and then equals 1 times 4, which is 4. So again, I took each individual number and multiplied it by the 4 that we needed. Okay? Now I'm going to do the same thing, add them straight down. Okay, so 8x minus 8x cancels. Negative 2 plus 20, that's positive 18y, equals 50 plus 4, which is 54. Now this, we can literally solve it for this variable. So I'm going to divide by 18 to get y alone, and we get y equals 3. So I'm going to box that in because we've got a solution. Yeah. Okay, anyways, step 4. Plug this solution into your first, or for your first variable, into either d or e to solve for a second variable. So we're going to take that y equals 3 and we're going to plug it in. So we're going to plug y equals 3 into either equation D or equation E. It literally makes zero difference. So I'm just going to choose D because it comes first in the alphabet. So we have 8 times x, I'm looking back at this equation right here, minus 2 times our y, which is 3, and then equals 50. Okay, so we have to solve that real quick. We've got 8x minus 6 equals 50. Add 6 to both sides. 8x equals 56. Divide by 8, and x equals 7. Woohoo! We're solving away. We're doing a great job so far. So we've got x, we have y. But remember, I should have totally told you this. We should have checked to make sure that our y is what the solution said. And good, we are doing perfect. Y is 3. And then once we know that y is 3, we move on to solve for the next variable, which was x. X is 7. Doing great. Now, if not either of these numbers did not match up, that means we made a mistake and we have to go back to the beginning. Solve again. All right, but we didn't. We're doing good. So now we're going to plug x equals 7, and that's an ampersand. Y equals 3 into, this says in step 5 that we can do it in either equation A, equation B, or equation C. So you pick, doesn't matter. I'm going to just stick with equation A, again, because it comes first in the alphabet. Sometimes I pick one that looks easiest to plug into. I don't know that one's easier than the other in this case. So we have 2 times our x value, which is 7, plus the y value, which was 3, plus z equals 15. And again, this was equation A way back up at the top. All right, so we're going to solve this. This is 14 plus 3 plus z equals 15. 14 plus 3 is 17 plus z equals 15. Subtract 17 and we have z equals negative 2. And if I look back at my solution from way up above, z is supposed to be negative 2. So step 6 is to literally just write your solution, what your final answer should be. And remember, it goes in x, y, z order, so it will be 7, 3, negative 2. And you want your final solution to match perfectly with the solution you had up above from your calculator. Okay, so I know it seems like a lot of steps. We're going to do another practice problem. And then if you need a third one, there will be a third one for you if you need it. All right, so this is what it's going to look like on your CFU, on your test, on any paper where you have to solve for a system of equations. They give us x, y, and z here, so we're going to first type this into our calculator, get our solution. Okay, so we should have 3 answers in the order of x, y, z. So I'll show you, again, the calculator steps one last time, and then you should be able to do them on your own. All right, so first things first, we're going to type in our equations into the calculator. So we're going to hit menu, and then it was choice 3 for algebra, choice 2 for solving the system of equations, change the number of equations to 3, hit OK. And then you just type them in. So negative x, x's, remember, are down at the bottom in the alphabet spot. Negative x, let's see, plus 5y, plus 5z, equals, remember, is right next to or below the control button. So equals 15. Move down, type in the next one, negative 5x minus 5y plus z equals 15. You're going to want to type in your equations every single time so you can get the answer and start comparing your answer as you solve with the actual answer. Alright, once I have it typed in, I just hit enter. And it gives me the answer. X should be negative 5, y should be 2, and z should be 0. Okay, so we're going to write that down real quick. Alright, so we've got negative 5, we've got 2, and we have 0. So I'm going to go through and look at my x's, my y's, and my z's, figure out which one's going to be easiest to eliminate. So when I look at my x's, technically there is a negative 1 right here. So x's, we've got negative 1. I didn't mean to erase that. We have a negative 1, a negative 5, and a negative 3. They're not the same numbers, and they are not opposite signs, so that's probably not easiest. We have a 5y positive, a negative 5, and a negative 5. That's looking good so far. And then z's, we have a 5z, we have a 1z, if you choose to write that 1 in, and then we have a negative 11. So it looks like y's are going to be easiest to eliminate. So I'm going to say eliminate y. And we're going to do that first. Alright, so step number 1. After we have our equations labeled as A, B, and C, we have to decide what are we going to add to one another. It looks like A is the positive one again. Again, this is just coincidence in comparison to the first one. So I'm going to stick with A plus B because these are same numbers, opposite signs. So we're going to do equation A plus equation B. So I write them out first, negative 1x plus 5y plus 5z equals 15. And then we have negative 5x minus 5y plus 1z equals 15. And remember that we are adding and we're going straight down. So negative 1 plus 5, or sorry, negative 1 minus 5 is negative 6x. Then we have 5 minus 5, which cancels. And then we have 5 plus 1, so that's plus 6z, equals 15 plus 15, which is 30. This becomes our next equation, which would be the letter D. I'm going to circle it because we're going to come back to it in a few minutes. Step number 2. Still eliminating y's, what 2 equations can we add this time? So I need a positive and a negative, same exact numbers to eliminate. So I'm going to look at, let's see, positive, which is A, and the next negative, which is C. So we're going to do A plus C. So I have to write the full equation first. I know it's a pain in the butt, but do it because you're going to make sure that you make 0 mistakes. Plus 5y plus 5z equals 15. And then we have C, which was the negative 3x minus 5y minus 11z equals 5. Okay, so again, we add straight down. I'm going to do this one in green just to change up the color. We've got negative 1 minus 3, so that's negative 4x. Y's cancel. 5 minus 11, so negative 6z. And 15 plus 5, so that's 20. And this will be equation E. We're going to circle this because we're going to use D and E to help us solve for step number 3. Step 3 has to use these 2 circled equations, D and E, so we have to use them somehow to eliminate our next variable. This one seems to happen pretty nicely. If I look at my variables here, we have negative 6 with an x, negative 4 with an x. That's not so nice. However, we have a positive 6 and a negative 6 for the z's. So that looks like it might actually be super easy. We don't have to multiply by anything. So we're going to just do straight up D plus E. Okay, so I'm going to write those equations. Negative 6x plus 6z equals 30, and negative 4x minus 6z equals 20. Add them up straight down. So when I do this, I have negative 6 minus 4, which is negative 10x. 6 minus 6 cancels, equals 50, because 30 plus 20 is 50. All right, so I get to solve this for x right now because it's almost there. I'm almost done, ready to solve, or almost done with solving. We're going to divide both sides by a negative 10. So then x equals negative 5. So I'm going to box this in, but then I'm going to zoom out so I can double check, make sure that x is supposed to be negative 5. So we've got that done so far. Beautiful. Okay, you see how I'm checking with my solution back up top? Negative 5 is x. All right, so we're on the right path. If I didn't find the right answer, I'd have to go back and rework to make sure I find the mistake that I would have made. So step number 4 is to plug x equals negative 5 into, we can either use D or E. Doesn't look like one's easier than the other, so we'll just use D. Okay, so now we have, let's see, negative 6 times the x value, which we just found was negative 5. And again, remember, we're plugging into D, which is this blue equation right here. Okay, and then we've got plus 6z equals 30. So we're going to solve this real quick. This is a positive 30 plus 6z equals 30. Subtract the 30 from both sides. And now we have 6z equals 0. Divide by 6. And so z equals 0. And before I box that in, I want to double check, is that correct according to my solution? Yes. So we're doing good so far. We've got 2 answers. We need the third. Okay, so step number 5 is to plug x equals negative 5 and z equals 0 into either equation A, B, or C. So it's your choice. It looks like A has maybe less coefficients. I don't really know. It doesn't matter which one you plug it into. I'm just going to choose A. Okay, so that's this equation way back up here. So the equation has a negative x plus 5y plus 5z equals 15. So we're going to write that down but plug in what we have. Starts again with a negative, and then our x value is negative 5. And then plus 5y, which we don't have yet. And then plus 5z, which we do have, times our z value, which was 0, and then equals 15. Okay, so my red x came here, my blue z came here, plugging into equation A from way back up top. All right, so we've got 5 here, positive 5, because negative negative turns positive, plus 5y. This is just going to cancel because it's a 0, and then equals 15. I'm going to subtract the 5, so we have 5y equals 10. And then divide by 5, and that gives us y equals 2. So I'm going to double check with my solution way back up top. It does in fact tell me that y should be positive 2, so we're looking good so far. We've got the negative 5, we've got the 0 for the z, and now we just found 2 for y. So remember, it's super important to find your solution first so you can make sure that you have the correct answer in the end. So I'm going to box this in, and then step number 6, if you recall, is just to write your solution set. So it goes in the order of x, y, z, and so we've got negative 5, 2, 0. And then this is our final answer. So something I want to point out to you real quick, I'm just going to zoom out so we can see this whole overall process. You want to first start by obviously finding your solutions. Secondly, you want to label your equations A, B, and C and choose a variable to eliminate first. And that's going to come from looking at the coefficients. As you can see, I did in the highlighted colors here. These coefficients for y were the same number, opposite signs. Okay, so that's what you're always looking for. Sometimes you might need to multiply by a positive or a negative 1, and that's okay. You can do that. You just remake the equation then. From here, we took 2 of those equations that were original and added them together straight down, adding coefficients, attaching the variable, so that we could cancel out these y terms. We did the same thing to cancel out y's again. Okay, so in step 1 and step 2, you are canceling the same exact variable. In step 3, we now use our brand new equations, D and E, to eliminate another variable. And again, you might have to multiply like we did in example 1. This one we got lucky. We had a positive 6z and a negative 6z already. But I'm, again, looking at coefficients, seeing if they're the same number and if they're opposite signs. If they are, that's a great thing. If not, then we got to get them there by multiplying by a coefficient. Then I'm adding those straight down, and I'm able to solve for x. As soon as I have x, I check it with my answer. Okay, check it with the original solution. Once I have my x, I'm going to work backwards, plugging back into an equation that's up here, either d or e. As soon as we do that, we get another variable. Once we have two variables, then we go all the way back up to the top to plug it in to one of the original equations, a, b, or c. So you work your way down with the equations, but then as soon as you have a variable, you plug it back into equations from back up top. Okay, so you work your way back up. All right, let's flip to the next page. So this one is an extra guided practice problem. So if you need it, stay with me. If you don't need it, don't worry about it. So this is extra guided practice if you need it. If you don't need it, then you just move on to your own practice problems. There's plenty of them for you to do. I think there's about 4 of them. Okay, so remember our first step is to find the solution. So if you're sticking with me, we're going to find the solution in the calculator. And I'm going to do that by hitting Menu, Choice 3 for Algebra, Choice 2 for Solve System of Equations, and then we have to change equations to 3. And then we're going to type in each individual equation. So I'm not going to show it on the calculator again, but I'm going to do it in my calculator so that I can get the answers right here. Okay, so I typed them in my calculator. As you can see, I've got these numbers. They go in the order of x, then y, then z. So these are the numbers I'm looking at. I typed these equations into my calculator. And so we've got x is 3, y is 1, z is -1. So we're going to write those down in our solution set over here. So then the next thing I want to do is look at my coefficients in these equations after I label them. So I'm going to label A, B, C. Okay, so we're going to zoom in just a little bit on this. So I'm looking at my coefficients, and let's see, we've got -3, +3, -3. That's looking good so far for these x's. My y's are looking at -3, +5, and a +2. They're not the same. The thing that looks good is the fact that they are the same number, opposite signs. With this z, we've got a 4z, a 1z, haha, and a 4z. So those are not all the same coefficient. I could try to eliminate z's if I wanted to multiply equation b by a number, but I think that we can just eliminate x's first. I should get out of the highlighter and into a pen. Eliminate x's. All right, so in order to eliminate x's, I've got to choose 2 of these equations, a, b, and c together to eliminate x's that have opposite signs, same coefficient. So it looks like a and b, I've got a negative and a positive. So I'm going to start by adding a and b. I don't have to multiply them by any number nor a -1 because they are already opposites. So we've got -3x minus 3y plus 4z equals -16. And equation b is 3x plus 5y plus 1z equals 13. So remember that we add straight down. I'm taking my coefficients, -3x plus 3x, and they cancel. Now we have -3y plus 5y, that's a +2y. 4z plus 1z is 5z. And -16 plus 13 is -3. Okay, so this becomes equation D. I'm going to circle it because we're going to come back to it in just a few minutes. Step number 2, still eliminate the variable x. So I look back at my equations. How can I eliminate x using 2 other equations besides a and b together? So it looks like, again, b is the positive, the one and only positive 3x, and c is another negative. So it looks like I can cancel x's right here, 3x minus 3x. And so we're going to add equation b plus c. So we've got equation b, 3x plus 5y plus 1z equals 13. And equation c is negative 3x plus 2y plus 4z equals negative 11. And just like last time, we add straight down. Okay, so now we've got 3x plus negative 3x cancels. We have 5y plus 2y is 7y. 1z plus 4z again is 5z. And this equals a positive 2 because 13 plus negative 11 is positive 2. This is equation E. So then our third step is to use equations D and E to try to eliminate a variable. So I'm going to go back to my highlighter and look at these variables here. We have a 2y and a 7y, so those are very different numbers, not opposite signs, not the same coefficient. So I'm hoping that z's look a little bit better. We have a 5z and a 5z. So those are the same number, we just have to multiply one of them by a negative. So it doesn't matter which one you multiply by a negative. I'm going to say that we're going to multiply this one, equation D, times a negative 1 on every single part. So we have a negative 1 times D plus equation E. Okay, so again, we're taking equation D, multiplying it by a negative 1 so that we have that negative 5z to be able to cancel with equation E's positive 5z. So now for equation D, we have negative 2y minus 5z equals positive 3. Again, just multiplying right here by that negative 1. And then equation E stays exactly the same. 7y plus 5z equals 2. And again, we add straight down. Okay, so adding these, we get 5y, z's cancel, equals 5. When we divide by 5 to solve for y, get y alone, we get y equals 1. Before I box it in, I want to double check back up here in my original answer. We had x is 3, y is 1, z is negative 1. So we got the y. That's a good thing. So I'm going to box it in. We're good there. Step 4 is to plug y equals 1 into either equation D or equation E, totally your choice, but it's got to go into the original. So not the new D where we multiply by negative 1, we want it to go into the original. So I'm going to go into equation D, or you could just choose E if that's easier for you. It's totally your choice. So it starts with a 2 times the y value, which we just found was 1, and then plus 5z equals negative 3. All right, so this gives us 2 plus 5z equals negative 3. Get 2 to the other side. 5z equals negative 5. Get the 5 away. So now z equals negative 1. Nope. And I just saw that back up top in my original. Z is negative 1, so we're doing great so far. Moving on to step number 5, we've got to use y and z and plug it back into one of the original equations. Okay, so I'm zooming out just a little so I can see the space I have. Plug y equals 1 and z equals negative 1 into, you can either go into A, B, or C. I see B very clearly on my paper because there's some stuff covering up equation A. So I'm just going to plug into B because that's what I can see right now. So we've got 3 times our x plus 5 times the y, which we found was 1, plus 1 times our z, which is negative 1, and then equals 13. So we're solving. We've got 3x plus 5 minus 1 equals 13. You should be able to solve that pretty easily. just by simply adding 5 and that -1. So this should give you 3x. I'm just going to move my work over here. 3x plus 4 equals 13. Subtract your 4, you have 3x equals 9. Divide by 3, x equals 3. And if I zoom back out so that I can see my full solution from the original calculator, x is 3. So we've got that, and then step 6 is to just write our solution. 3, 1, -1, because they're, again, in the order of x, y, and z. All right, that should do it. If you have any questions, please let us know. This, again, was just an extra guided practice. You should be practicing on your own. Make sure that you fill out this summary to list the main ideas and what you should do before solving, finding your answers in the blank. Have a good one.